Hello, my students. Today we are learning redox titration. Redox titration is the type of titration that deals a reaction where both oxidation and reduction occur simultaneously. This type of titration is the only type of titration that do not have an indicator. You will not use an indicator. This type of titration, it only involves two major solutions, majorly potassium magnate 7, a solution called potassium magnate 7, which is purple in color, and ammonium iron 2 sulfate or ammonium iron 2 sulfate. It deals only these two solutions. So whenever you want to do such kind of question, it's very simple. It has three sections. It has three phases: phase 1, phase 2, phase 3. So the phase 1 we are learning this lesson. Phase 2 we are going to learn the next lesson, and phase 3 that's our last lesson about. We concluded with the phase 3. So there are three formats in which they bring in the exam. So the first format we are going to see it right now. So here we have this question. You are provided with the following: 15.8 gram of potassium magnate 7 containing 250 centimeter cubic of what of solution, and label as a solution A. 12.5 gram ammonium iron 2 sulfate contains 100 centimeter cubic of solution, label as solution B. So we have procedure here. The procedure is saying fill the burette with potassium magnate 7. Then you using a pipette, you place 25 centimeter cube of solution B in a clean conical flask. Then there is no indicator you use here. There is no indicator. Then you fill the table. Usually the procedure remains the same: 12.5, 12.5, 12.5. This is the final volume reading. The initial 000. Then the volume of solution A used, which is potassium magnate 7, is 12.5, 12.5, 12.5. The first question is asking calculate the average volume of solution A used. To calculate the average volume, you add these three as we used to do it. Yes, 12.5, 12.5 divided by 3. Average volume is equal to 12.5, 12.5, 12.5 divided by 3. Then when you add all of them, you'll get 37.5. Then divided by 3, you get 12.5 centimeter cube of solution A used. This is the volume of solution A used. Very good. Let us see the next questions. We have these questions. Calculate the concentration in gram per liter of solution A. Concentration in gram per liter of solution A to calculate. In solution A we have the mass 15.8 gram and we have the total volume, which is 250 centimeter cube. To calculate now the concentration in gram per liter, it is very, very simple. This is what we do. 15.8 gram is equal to 250 centimeter cubic of solution. We are answering A, part A. 15.8 gram, which is the mass of the solution A, is equal to total volume, which is 250 centimeter cubic. What about 1000? You cross multiply, then 1000 multiplied by 15.8 divided by 250. Then you'll get 63.2 gram per liter. This is the concentration in gram per liter of solution A. That's how you answer A. Let's go to B. Part P, it's asking the concentration of solution. The concentration of solution A. Here is A. A. Solution A in moles per liter. To calculate the concentration of solution A in moles per liter, solution A is potassium magnate 7 and it's written potassium magnate O4, which means 4 oxygen. Potassium 39, magnate 55, oxygen 16. Then to calculate the concentration of solution A in moles per liter or molarity can be obtained by using this formula: concentration gram per liter over RFM. Concentration gram per liter already we have obtained here, it's here, but we don't have the molarity, the RFM, the RFM. This RFM we don't have. To get the RFM, you use the compound potassium magnate 7. Potassium K is 39. Here we have in the bracket 39. Mn, which is magnate, Mn is 55. Then oxygen O is 16, and we have 4 oxygen here. 4 times 60, 16. Then here you will get it 39, which is potassium, plus 55 manganate, 64, which means 4 times 16, which is the oxygen. You will get 158. Then therefore molarity is equal to 63.2, which is the concentration that we have obtained here, divided by the RFM, which is 158. Then you get 0.4 molar of potassium magnate 7. That's how you answer part B. I think you have understood it. We have part C. Part C is asking the number of moles of solution A used. The number of moles of solution A used. In solution A, we have the molarity 0.4 molar. We also have average volume, which is the volume used. Volume used 12.5. Therefore, this is what we do. 0.4 molar is equal to 1000. 0.4 molar is equal to 1000. 12.5 centimeter cubic, which is the average volume, the volume used, how many would equal to X? We don't know. You cross multiply this one, then you cross multiply this one and this one. 12.5 times 0.4. 0.4 times 12.5 divided by 1000. When you do the calculation using the calculator, this is what you get. 0.005 moles of solution A used. This is the volume, this is the number of moles of solution A used. That's how you do it, part C. That's how you do it, part C. Part C, I think you have understood it, because we have the molarity and we have the volume used, which is the average volume. Molarity is equal to 1000, the average volume is equal to X, which is 12.5. Then that's how you get part C. Part D, the concentration of solution B in gram per liter. Let us check solution B. Solution B, we have molarity, the mass of solution B is 12.5 gram, total volume 100. Then to get the concentration in gram per liter, this mass is equal to this volume. Then what about 1000? That's what we do. 12.5 gram, which is the mass of the solution B, is equal to the total volume, which is 100. What about 1000? Then you cross multiply. 1000 times 12.5 divided by 100. Then you will get 125 gram. This is the concentration in gram per liter of solution B. Solution B. Then that's how you do solution equation D. The concentration of solution B in gram per liter, we have obtained it by how? By equating the mass. By equating the mass to 12.5 gram is equal to 100. What about 1000? That's what we have done it in a simple way. Then we have obtained the answer as 125 gram per liter. Then the next question here we have question E. D is, we have done D. Question E says concentration of solution B in moles per liter. Given that iron 2 sulfate, here we are missing something. So let me add that things here that we are missing. There is something that we are missing here. We are missing ammonium iron 2 sulfate. Let me capitalize it. Iron 2 sulfate. Sulfate 4 molecules of oxygen. Yes, because these two that you see here is being contributed. Sorry, these two, I'm doing something very wrong. I'm doing something very wrong. Okay, let me stabilize my pen. I think now it's okay. Okay, these two that you see here is contributed by the sulfate, and this compound can be read as iron 2 sulfate, ammonium sulfate, 6 molecules of water. Now, anyway, they're asking the concentration of solution B in moles per liter, which means the molarity of solution B. This part is very important. To calculate E, this is what you do. We have to calculate by using the formula. Says that concentration molarity is equal to concentration gram per liter of RFM. We use that formula. Let us see by D. So by D, we will say molarity is equal to concentration gram per liter of RFM. Concentration gram per liter of solution B, we have 125. Then, how do you get the RFM? RFM of iron 2 sulfate, ammonium sulfate, 6 molecules of water, you calculate it. According to the bracket, the question that they give us, in the bracket, we have iron 56, nitrogen 14, hydrogen 1, oxygen 16. Then therefore, iron 56, here we have iron 56, sulfur 32, although they give us, they have not provided in the bracket, but sulfur is 32. Oxygen 16, 4 times 16, we have 4 oxygen here. Then plus nitrogen, we have 14, but this 2 is multiplied anything inside the bracket. Nitrogen 14 times 2 times 2. Then hydrogen 1, we have 1 hydrogen, 1 times 4, we have 4 hydrogen times 2. This 2 that we are multiplying is the one outside. Plus sulfur again 32, sulfur 32, then oxygen 16 times 4, then plus 6, which is here, then multiplied by anything from the water, which is 2 plus O, oxygen, which is 16. Then here when we get 56, then 32, we write it again, 4 times 16, 64, 14 times 2, 28, 1 times 4 times 2, 8, then 32, then 16 times 4, 64, then water, we have hydrogen, 2 hydrogen plus 1 oxygen, 16, 18, multiplied by 6. This 6 is multiplied as a coefficient. Then when you add all this from here up to this, when you add, you'll get 284. You'll get 284 plus 6 times 1, 18, you'll get 108. Then when you add all, you'll get 392. Then to get now molarity is equal to concentration gram per liter, which is 125, divided by the RFM, you obtain 392. Then this is your 0.32 molar of solution B. That's the concentration of solution B in moles per liter. Good. Now our next question, we have question E. We have done question E. Question F, the number of moles of solution B used. To calculate the number of moles of solution B used, do we have the volume used? We have the volume used here, 25 centimeter. Using a pipette, 25 centimeter cube of solution B. We have the volume is 25. And also we have molarity we have obtained right now. Since we have obtained molarity right now, molarity is equal to, which is 0.32 is equal to 1000, 25 is equal to how much? Then you cross multiply. You'll get 0.008 moles of solution. What have I done? Let me repeat it here. This is my molarity. This is my molarity, 0.32. And the volume used of solution B, is 25 centimeter cubic pipette volume. Then what do you do? Then this is what you do. 0.32 moles of the molarity is equal to 1000. 25 centimeter cubic is equal to how much? Cross multiplication. You multiply 25 with this 0.32, then divide by 1000. This is what you get when you do that calculation using the calculator. 0.008 moles. That's how you do question F. We have question G. Question G is asking the mole ratio of solution A to solution B. To calculate the mole ratio of A to B, you have to get the number of moles of solution A. Then you get the number of moles of solution B. Then you mole ratio it. The number of moles of solution A was where? Let us see it. The number of moles of solution A, where is it? The number of moles of solution A, there is a place where we have obtained this, the molarity. It was the next question. The number of moles of solution A is here. This is 0.005 moles. This is the number of moles of solution A. Then, since we have the number of moles of solution A, we have to get the number of moles of solution B. The number of moles of solution B is also here. The one that we have obtained right now, here. Then, to get the ratio of solution A to solution B, you write solution A. This is the ratio of A to B. Then, this is the number of moles of solution A, and this is the number of moles of solution B. You divide both sides, the smallest value. The smallest value here is, when you compare 0.008 and 0.005, 5 is less than 8. Then you divide both sides by 0.005. Then you cancel this one and this one. This one, when you cancel 0.005 to 0.005, you'll get 1. When you cancel this one by this one, you'll get 1.6. You round it, then you get 2. So the mole ratio of the reaction is 1 to 2, according to the calculation what we have done it. Okay, I hope you have understood this lesson today. If you have any question, please, you can write in the comment section. These lessons are very important. Whatever I'm doing here is KCC past papers, and it will help you if you are a candidate or if you are a semi-candidate. It will help you in one day, one time. So please subscribe and also share your friends so that every time that I upload a new video or a new lesson, you will receive the notification of my lessons, so that everybody receives this lesson, and God will reward you, and you will get a reward from God even if you share with your friends who do not have a teacher or who has problem with such kind of concepts. Thank you.